Okay, let's go ahead and get started. Please write down the objective. What are we doing today? I will write recursive and explicit equations. Okay, so we are going to be talking about the difference between an explicit rule today and a recursive rule. So basically, in the past, what we've had have been sequences, right? It's either been an an arithmetic sequence or a geometric sequence. Well, with an explicit rule, they give us a formula that can solve for any term. Right, just like yesterday with your geometric sequences, they gave you a formula, and then if we said find the 64th term, you just plug in 64 into your equation and you'd be able to figure out what the answer would be. Now that's different than a recursive rule though. A recursive rule is a formula that can only solve for the next term. As in, this formula can only solve for the term after what was given to me, and then after what was given to me. Okay, so recursive rules. This is the new stuff. Okay, for an arithmetic sequence, and a recursive rule is going to say a to the n equals a to the n minus 1 plus d, where d is your common difference. Right? It's the number that's being added over and over and over again. That's what makes the pattern. Geometric sequence is a to the n equals r times a to the n minus 1, where r is your common ratio. That's the number that's being multiplied over and over and over to make that sequence. All right, explicit rules. You've already actually learned these two. You learned geometric yesterday. Arithmetic you learned a few chapters ago. This one said a to the n equals a1 plus parentheses n minus 1 times d. Remember where d again is your common difference and a1 was your first term. Okay, the explicit equation for the geometric sequence, what we talked about yesterday, was a to the n equals a1 times r to the n minus 1. So again, a1 is your first term, and then r is your common ratio. Okay, now that you know these two, let's go ahead and start a few examples. Number 1, it says determine whether the recursive rule, okay, so these are all recursive rules. We're looking at this box right here, is arithmetic or if it's geometric, okay? How do I decide what is the difference between the two? Well, if you take a look at the original equation, do you see how they really kind of look the same? The only difference is that arithmetic has a plus something at the end, and then geometric has a times something in the beginning, okay? So that's what you're really looking for. So take a look at this one. You have a plus something at the end, so if you have a plus something that was arithmetic. Okay, you try. Go ahead and pause the video. Try this one yourself, please. Okay, so for this one, did you see that you have a times something in the beginning? So which one has times something in the beginning? Geometric. So this one's geometric. All right, let's go to number 2. Number 2 says write the first 6 terms of the sequence, then graph the sequence. So my first term is 0, right? A1 stands for 0. So my first term is 0. It looks like my rule, it has a plus something at the end. So I know if it has a plus something, it must be arithmetic. And that also means that d is my common difference. This is a number that's being added over and over and over. So my first 6 terms, I have 0. 0 plus 3 is 3. 3 plus 3 is 6. 6 plus 3 is 9. Then 12. Then 15. Okay, those are the first 6 terms. How do I graph this? Well, I only see one number. So how can I graph a point that has 2 numbers, something comma something? Because when I do this, I'm going to realize that this is my first term, my second term, my third term, my fourth term, my fifth term, my sixth term. So it's like this is a point, 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 this is a point. Okay? So when I graph this, I'm going to have my first, second, third, fourth, fifth, sixth term. Looks like the y-axis goes as big as 15, so let's count by 2s. I have 2, 4, 6, 8, 10, 12, 14, 16. So graph 1, 0. Then I have 2, 3. I have 3, 6, 4, 9, 5, 12, 6, 15. Didn't we say a long time ago that an arithmetic sequence was going to be linear? Well, look at your points. It's linear, right? It's going to form a straight line if I were to connect those together. So I know I got it right. Let's try this one now. Okay, this one, is it arithmetic or geometric? Well, look, you have a times something in the beginning. So you know for sure that this is going to be geometric. Well, if it's geometric, what does this 5 mean? 5 is R. R means the common ratio. That means that's the number being multiplied over and over and over again. So my first term is 1, because A1 stands for the first term. 1 times 5 is 5. 5 times 5 is 25. 25 times 5 is 125. Then I have 625. Then I have 3,125. So again, if I want to graph this, I have my X and Y axis. Okay, how do I know what my points are? I'm just going to number them. My first term, second term, third term, fourth term, fifth term, sixth term. And these are my points. Okay, so on the bottom I have 1, 2, 3, 4, 5, 6. On the top or the side y-axis looks like I go all the way to 3,000. So maybe 3,000, let's count by 500s. So 500, 1,000. Then I have 2,000. Then 3,000, and then 4,000. Okay, so I have 1, 1, way down here. 2, 5, still way down here. 3, 25, not much higher. 4, 125, well, if this is 500, 125 maybe is right here. 5, 625, okay, so like here. 6, 3,125. So remember how we said a long time ago geometric sequences were going to be exponential? Well, isn't this an exponential graph? Okay, go ahead and pause your video, please, and try the 2 U-tries. Okay, for this one, so looks like I have a minus something at the end. So if I have a minus something at the end, this makes it arithmetic. That also makes it my common difference. I'm going to subtract 8, subtract 8, subtract 8. So what are my terms? I start with 18. Right, because that's A1. I have 18 minus 8 is 10. 10 minus 8 is 2. 2 minus 8 is -6. Then -14, then -22. What are my coordinates then? This is my first, second, third, fourth, fifth, sixth term. These are my points. Okay, when I want to graph this, it's a little bit more difficult because I'm graphing positive numbers and negative numbers. Okay, so make sure that your X and Y axis reflects that then. So here's 0. Let's say this is 1, 2, 3, 4, 5, 6. I'm going to maybe count by 5s because I have to go up to 18. So 5, 10, 15, 20. So this is -10, -20. Okay, so plot 1, 18 is right about here. 2, 10, 3, 2, 4, -6, 5, -14, 6, -22, about right here. Oh, look, it's arithmetic, which means it's linear, and yes, that does form a straight line. Okay, next you try. I have a times 2.5 in the beginning, so I know that this must be what? Geometric. So this is my common ratio. It's being multiplied by 2.5 every time. So what are my terms? I have 4. 4 times 2.5 is 10. 10 times 2.5 is 25. 25 times 2.5 is 62.5. Then I have 156.25 and then 390.625. Okay, so first term, second term, third term, fourth term, fifth term, sixth term. No negatives to graph, so I can just have a positive XY axis, quadrant 1. I have to go up to 390, so maybe let's count by 50s again. So I have 1, 4, 2, 10, 3, 25, maybe here, 4, 62.5, 5, 156.25, 6, 390. Oh, look, it's exponential. And if it's exponential, that means it's geometric. All right, backside. Okay, this side is a little bit more difficult. What I'm actually going to do is I took my front side. I'm looking at these two boxes on my front side just so it's easier to look off of. Okay, so for number 4, it says write a recursive rule. So I know that my answers are going to be one of these two because these are where the recursive rules are. And what am I given? These are my term numbers, these are my answers. So what I want to do first is I want to figure out which rule am I going to write. Is it arithmetic or is it geometric? So let's see. From 4 to 28, looks like I times 7. 28 to 196 times 7. 96 to 1,372 times 7. So I know this must be geometric. So I'm going to write the geometric rule. I'm basically going to copy this down but plug in random numbers for what I see here. Okay, so I start with a to the n equals r. R is my common ratio. What number gets multiplied over and over and over, which would be 7 times a to the n minus 1. Don't forget when you write recursive rules though, they're always going to ask you what is your first term. So your first term is 4. You have to write that down. So that's my answer. Okay, go ahead and pause your video. Please try the next one by yourself. Okay, for this one, let's see. So first of all, again, remember, you have to decide, is it geometric or is it arithmetic? So from 6 to 11, that's 6 times nothing, or no whole number is 11. So let's try adding. Oh, plus 5. 11 plus 5 is 16. 16 plus 5 is 21. So I know that it's arithmetic, so I'm going to be copying down this equation. Okay, so if I'm copying down that equation, I have a to the n equals a to the n minus 1 plus d. D is your common difference. Where is your common difference? Oh, 5. That's the number being added over and over and over. So that's my answer. Don't forget, though, you should always write what your first term is. Your first term is 6. So that's your answer. Okay, let's take a look at number 5 now. Take a look at what this says. So I have an equation. I need to write it something like this. Well, I want to see if it's arithmetic or geometric. Doesn't this equation look like this one, right? Explicit equation for a geometric sequence. I have a number, then I have something to the n minus 1 power. Yeah, it does. Okay, so I know they're actually giving it to me as a geometric sequence. So again, if I know it's geometric, go back to geometric and start copying this down. So I know it's going to be a to the n equals r. R is your common ratio. Well, if I want to know what my common ratio is, why don't I look at the original explicit equation? R was the number with the exponent, so the number connected to the exponent is 2. Which means my common ratio must be 2. So that's 2 times a to the n minus 1. Remember, you should also include what your first term is. Your first term, well, I'm not quite sure what my first term is just by looking at this, so go back to what this equation looked like, right? Because it was a to the n equals a1 times r to the n minus 1. Oh, a1, that's my first term. That took the place of 5, so my first term must be 5. Okay, please pause the video, go ahead and try the next one by yourself. Okay, for this one, take a look. So first of all, do you see how you have a plus 3 at the end? This plus 3 must mean that it is arithmetic. Okay, so it's going to look like this equation. So I have a to the n equals a to the n minus 1 plus d, your common difference. Okay, so here's the thing. Your common difference is not 3. Okay, the reason why is because it doesn't look like this equation right here. Okay, so how do I figure out my common difference? Well, there's a little bit of stuff I have to do first. Okay, if you take a look at this, why don't we figure out what a1 is? Well, I don't know what a1 is, but can't you take this equation and say negative 7 times 1, because that's the number you're looking for. You're looking for term number 1 plus 3. Well, isn't that negative 7 plus 3, which is negative 4? So that's a1, negative 4. Okay? How do I find what the common difference is going to be? Well, take a look at your equation. Okay? If I have negative 4, if I look at this equation for arithmetic, do you see how the common difference, which is D, if I had distributed this, then it would be the number connected to the n. Well, what's the number connected with the n? The -7. That's how I know that the common difference is -7. Okay, this equation is basically the, I guess, the distributed version of this. Okay, so this would be my answer. Okay, moving on. Write an explicit rule. Okay, so now I know that my answer is going to be one of these two, because it has to be explicit for the recursive rule. Okay, so if they give me recursive, then why don't I write what this is? Well, +5, so I know this was arithmetic. So I'm going to write the original arithmetic formula on top. This is a to the n equals a to the n minus 1 plus d. Okay, so now if I want to write it as explicit, I'm going to write a to the n equals, just copy, right? A1. Oh shoot, what is A1? I'm not quite sure what A1 is, but it says right here, okay, -10 plus parentheses n. N is still n, what I'm looking for, -1 times d. I'm not quite sure what d is, but look, the original formula said that d was 5. So this is my answer. Okay, number 7, they give it to me as a explicit rule. I see that it's times something, so I know it's geometric. Okay, so I'm going to write the original geometric rule on the bottom. It said a to the n equals r times a to the n minus 1. So now I'm going to write it as an explicit rule. So copy this down and just plug in the numbers. I have a to the n equals a1. What is a1? 14. Times r. What is r? It says that it's -2 to the n minus 1. And that's it. Okay, please pause the video. Try the next two by yourself. Okay, let's see what we got. So for this one, I see a ×3, so that means it must be geometric. So I'm going to write the original geometric rule on top. A to the n equals r times a to the n minus 1. Okay, so now write it as an explicit. A to the n equals a1. They said a1 is 4 times r. Look at your original equation. R took the place of 3 to the n minus 1. Okay? Next one, oh, plus 11 at the end. Plus 11 at the end must mean that it's arithmetic. So I have a to the n equals a to the n minus 1 plus d. So now when I turn it into explicit, I have a to the n equals a1. What is a1? 6 plus parentheses n minus 1 times d. What is d? Look at what takes the place of it. 11. So that's my answer. Okay, a few more, then we're done. Number 8, graph the first 4 terms of the sequence with a given description, write a recursive rule and its explicit rule for the sequence. So it says the first term of the sequence is 8. So my first term is 8. In other words, a1 equals 8. Okay, each term of the sequence is 12 more than. Isn't more than plus? So if I'm adding 12, adding 12, adding 12, then what does it make it? Arithmetic. Right? Because arithmetic means I'm adding. That means my common difference is 12. Okay? So 12 more than the preceding term. So if I have 8, 12 more than 8 is 20. 12 more than 20 is 32. 12 more than 32 is 44. And it says to graph. So here's my first, second, third, fourth term. Remember how we did this earlier? How do you know what your coordinates are? First, second, third, fourth. These are your coordinates. If I have to go up to 44, maybe I can count by 5s. Okay, so 5, 10, 15, 20, 25, 30, 35, 40. So I have 1, 8, 2, 20, 3, 32, 4, 44, probably up here. And look, straight line, which means it's arithmetic. Okay, next part of the question is asking me write the recursive rule and write the explicit rule. Okay, given this information. So, recursive rule for arithmetic says a to the n equals a to the n minus 1 plus d. Common difference, what is it? 12. Remember, for recursive rules, we also need to write what is a1, which was 8. Okay, explicit rule. Right here. Copy it down. A to the n equals a1. What is a1? 8 plus parentheses n minus 1 times d. What's your common difference? 12. So that's my answer. Please pause the video, try the next one by yourself. Okay, this one, the first term of the sequence is 81. A1 equals 81. Each term of the sequence is 1/3 the preceding term. If it's 1/3, that means it's times 1/3, times 1/3, times 1/3. So your common ratio, R, is 1/3. Okay, so what are the first 4 terms? You start off with 81. Type it in your calculator. 81 times 1/3 is 27. 27 times 1/3 is 9. 9 times 1/3 is 3. So when we graph this, my first, second, third, fourth term, how do I know what my points are? Well, there we go. Looks like I have to get all the way up to 81, so let's count by tens. 10, 20, 30, 40, 50, 60, 70, 80. So 1 comma 81, 2 comma 27, 3 comma 9, 4 comma 3. Oh, look. It's exponential and it's geometric. Okay, so recursive rule and then explicit rule. Recursive for geometric says that it would be a to the n equals r, what's my common ratio? 1/3, times a to the n minus 1. Remember, don't forget to write what is your first term? 81. Second one, explicit for geometric says a to the n equals a1. What is it? 81 times r, what is your common ratio? 1/3 to the n minus 1. That's it. All right, let's do the last one together. Number 9, write the first 5 terms of the sequence, determine whether the sequence is arithmetic, geometric, or neither, and then explain. So here's a formula that I'm basically plugging it into. Okay, so A1 is 4, so I know I start with 4. So basically this is saying take half of my first term, which is 4, so half of 4 is 2, 2 plus 6 is 8. Okay, do that again. So now I'm plugging in 8. Half of 8 is 4, 4 plus 6 is 10. Now do that with 10. Half of 10 is 5, 5 plus 6 is 11. One more time with 11, because it's first 5 terms. Half of 11 is 5.5. 5.5 plus 6 is 11.5. So is this arithmetic? Plus 4, plus 2. No, they're not the same. So no common no common difference. Okay, let's see if it's geometric. This would have been times 2. This, no, not times 2, so it's not geometric. So it's neither. Why? Because there is no common difference or ratio. And that's why. All right, have a great night. Please ask your teachers if you have any questions. Goodbye.